Welcome to this explainer. Look, today we're taking on what is absolutely a high-stakes mission, and that is executing a flawless concrete pour. If you spend any time on a construction site, you know reinforced cement concrete, or RCC, is completely unforgiving. You literally get one shot to get it right, because once that concrete sets, your mistakes are quite literally cast in stone. That's exactly why having a rigorous step-by-step checklist isn't just a good idea, it's an absolute necessity. So we're going to walk through the ultimate RCC site checklist today, using real, authentic site terminology and firmly grounding everything we do in the gold standard of Indian construction.
So I want you to answer honestly here. Is your site truly IS code compliant? It is so incredibly easy to fall into the trap of just doing things the way they've always been done, right? But relying on habit instead of strict engineering standards, well, that's exactly how structural integrity gets compromised. If you want to guarantee safety, guarantee durability, and build a structure that actually stands the test of time, you have to follow IS 456-2000 standards to the absolute letter. This explainer is going to show you exactly how to do that, essentially transforming you from someone who just kind of watches a pour happen into someone who completely commands quality control on site. Okay, let's dive into this. Here is our chronological workflow. Step 1 is before concreting. Step 2, during the concrete pour. Step 3 is after concreting. Step 4 covers mandatory site tests. And finally, Step 5, common mistakes. Consider this your ultimate site guide. Section 1, before concreting, set up for precision and safety.
Now, the foundation for a flawless pour happens way before a single drop of concrete ever arrives. Precision here is literally everything. If you rush this preparation phase, you are setting yourself up for an incredibly stressful and, let's face it, likely defective pour. First things first, you must have the approved structural drawings physically on site, not buried in an email thread back at the office, in your actual hands on site. You've got to verify the column, beam, and slab sizes, as well as their centerline, level, and alignment. Next up, look at the shuttering. According to IS 456, Clause 11, it must be tight with absolutely zero leakage, none. If you have gaps, the cement slurry is just going to bleed out, leaving you with weak, honeycombed concrete. Ensure form oil is properly applied so you can actually get the formwork off later, and physically check that all props and supports are fully secure. Finally, just your steel. The binding wire has to be tight, and the chair bars must be properly spaced to maintain the mesh distance.
Now, what's really interesting about this next part is how these tiny little things act as the invisible spine protecting your reinforcement. I'm talking about cover blocks. Mandated by IS 456 Clause 26.4, these are mandatory spacers used to maintain the exact specified distance between the steel reinforcement and the formwork. If you ignore these, your steel gets pushed right up to the edge of the concrete, exposing it to air and moisture. And we all know what that means: rust, expansion, and eventually the concrete spalling and just falling apart. It is a critical failure point if you skip it. And this brilliantly illustrates how everything needs to come together before the pour. For your final pre-pour layers, you've got to verify the bar diameter and spacing against your drawings. You also need to verify lap lengths and anchorage as per Clause 26.2.5. Before you even think about giving the green light, ensure all electrical conduits, plumbing sleeves, and embedded items are perfectly set in their correct positions. Because once that concrete is poured, moving a plumbing sleeve means breaking structural concrete, which is an absolute disaster. Finally, confirm your concrete grade, whether it's M20, M25, whatever it is, and ensure that the mix design is fully approved according to IS 10262. Everything must be perfectly aligned.
Section 2, during concrete pour, the action-packed moment of truth.
All right, the transit mixers are arriving, the pumps are running, the site is loud, it's busy. In this action-packed moment, timing, technique, and strict adherence to the code are everything. You can't pause, and you definitely can't second guess. So burn this number into your memory right now. 1.5 meters. This is the absolute maximum freefall distance for pouring concrete. Why is this single number so unbelievably crucial? Well, if you drop concrete from a height greater than 1.5 meters, the heavier aggregates actually fall faster than the cement paste, and that causes segregation. The mix completely separates, and what lands at the bottom of your column or wall is basically a pile of loose rocks with zero binding strength. Control your drop height always.
Let's walk through the active pouring steps. Step 1. As soon as that concrete arrives, conduct a slump test per IS 1199 to check workability, and strictly enforce the locked-in water-cement ratio. Never alter it. Step 2. Pour continuously. You have to keep a steady pace to prevent cold joints. Those are the weak points where old concrete hardens before the new concrete is poured on top of it.
Step 3, use a needle vibrator for proper compaction. This is absolutely non-negotiable. You have to remove trapped air and prevent honeycombing. But hey, be careful not to over-vibrate and cause the segregation we just talked about. Finally, step 4, prepare and label your cube samples according to IS 516. Label them accurately with the exact date, grade, and location of the pour.
Section 3. After concreting, patience dictates strength.
So the high-energy action is over, and now patience dictates strength. Concrete doesn't just dry out like a coat of paint, right? It cures through a chemical reaction called hydration. And that reaction requires time, moisture, and close monitoring to build the structure's ultimate strength. This brings us to the crucial 24-hour rule. A day after the pour, you need to check the status of your formwork. When it is actually time, remove the shuttering strictly according to the timelines in the IS 456 guidelines. Seriously, don't rush it just to reuse the boards somewhere else on site. Once the formwork is off, you must conduct a highly critical visual inspection. You're looking for any signs of honeycombing, cracks, or surface defects that might signal a problem with the pour. This is also when you're going to start tracking those 7-day and 28-day cube test results. So the crucial point here is how curing times drastically differ depending on your materials. Just listen to how this breaks down. According to IS 456, if you're using ordinary Portland cement, or OPC, you've got to cure the concrete for a minimum of 7 days. But if you're using blended cement, which, let's be honest, is very common today, that minimum curing time jumps to 10 to 14 days. You have to keep that concrete moist. If you stop curing too early, hydration just stops, and your concrete will literally never reach its design strength.
Section 4. Mandatory site tests, the crucial safeguards of your mission.
Look, you can't just look at concrete and just somehow know it's strong, right? You need mathematical, scientific proof. These mandatory site tests are the essential safeguards that mathematically prove your structure's integrity. Consider this your ultimate cheat sheet of codes. Workability, that's the slump test under IS 1199. Ultimate strength, the cube compression test under IS 516. Need to know the exact criteria for whether a batch of concrete is accepted or rejected? That'll be IS 456 Clause 16. Your reinforcement steel has to comply with IS 1786. The scientific recipe for your concrete mix is governed by IS 10262. And the quality of your sand and stone, the aggregates, must pass IS 383. Guys, these aren't suggestions. They are the only way to scientifically validate your concrete pour. Section 5. Common mistakes. The villains that threaten structural safety. Let's move on and see how this all builds into identifying the dangerous shortcuts that can completely ruin an operation, despite perfect planning. Even with a flawless plan, site realities can really tempt workers to take shortcuts. But remember this mindset. Never compromise on the basics. Site shortcuts lead directly to structural failure. Every single time you let a small mistake slide on a site, you are signing off on structural weakness. This isn't about being overly strict, it's about acknowledging that physics and chemistry simply do not care about your deadlines. Avoiding these dangerous shortcuts matters deeply for the long-term safety of the building.
Let's rapidly run through these severe mistakes. Placing reinforcement without cover blocks, absolutely fatal to your steel. Adding extra water to the mix at the site, this is a worker's favorite trick to make shoveling easier, but it completely destroys compressive strength. Just do not let them do it. Inadequate or improper vibration, that leaves giant air pockets. Completely neglecting the curing process stops strength development dead in its tracks. Accepting concrete without passing cube tests means you are flying blind. And finally, pouring without strictly following your reinforcement drawings just ensures that errors are buried forever.
So knowledge is only power if you actually apply it. Will this checklist be on your next project, or will you leave your building's structural integrity up to chance? We've walked through the meticulous pre-pour checks, the intense rules of the pour itself, the vital patience of the curing phase, the non-negotiable IS codes, and the catastrophic mistakes to avoid. Take this IS code compliant guide straight to your site, enforce these standards, and permanently elevate your construction quality. Thanks for joining me on this explainer, and I will catch you on the next one.